Welcome to Dunder Data Pandas Challenge number 10. These are daily exercises to challenge your Pandas skills. You can take all of the challenges at python.dunderdata.com. Let's begin by reading in our employee data set. So in this challenge, you're going to return a data frame of strictly increasing salaries. Do this without rearranging row order, but by filtering out any employee who does not have a salary greater than the employee above him. So this is a more complex challenge. This one is worth 2 points instead of the normal 1. And for challenges that you might not understand what is happening, I highly recommend looking at the solution first. So there's nothing wrong with looking at the solution. It provides you the exact format of what needs to be returned, so it can really help you understand some of the wording if it's not clear. So the solution, if you look at it, isn't too many rows here. And what's important here is this salary column. So every employee in here will have a salary greater than the one above it, like so. Not just greater than or equal to, but it's strictly greater than the employee above it. So the way this would work if you were to sort of manually iterate through here is the first employee will always be kept. They will have the highest current salary. And then moving to the next employee, you would only keep that employee if it had a higher salary than the one above it. So this means that employees 1 through 15 did not have a salary greater than 87.5. So the first employee that had a higher salary was employee number 16, and they had a salary of 107. And it just so happened that the very next employee had a higher salary. And then we didn't get a higher salary until employee 48, which was barely higher. And so as you'll see here, what should happen, generally speaking, is that the number of employees it takes to reach a higher salary will increase, especially if they are randomly distributed, the salaries. So you can see here the highest salary occurs at employee 1732, and there's more than 24,000 in the data set. So this means that there's all the employees that come after this employee do not have a higher salary. And you can see there's actually quite a big gap between the last one and the one before. All right, so how do you do this? Well, let's go inside here and begin our code. So the first thing we can do is, and this will take more than one line, but is to drop the missing values. So this is a little hidden in the problem. It doesn't say that, but you need to be aware that there could be missing values. And this is just so that our comparisons always happen. We don't have any missing values in our final data set. So we will drop rows, but we'll only look at the salary column. So let's go ahead and execute that and see our result. So you can see here the number of rows dropped a little bit from the starting of 24,000. And we'll just reassign that to DF. So what we can now do is maybe we can keep track of the maximum salary. And the way we do that is with the cumulative max method. So let's go ahead and actually look at the salary. And before that, we can actually, since we'll use this again, we'll create a variable called sal is equal to just the salary column. And this will just help us look at, all right, let's take a look at the maximum salary over time. So you can see here, and if we do dot head 20, you can see that the first employee has the highest salary until employee 16, and then actually employee 17 comes and eclipses it immediately. So what we want to do is look at each of the employees' salary and test that it is, if it's greater than the cumulative maximum, then we can replace it, or then we can keep it. So we're going to keep going employee by employee and just test that is greater than the cumulative maximum above it. So what we'll have to do here is actually shift this down 1, and by default the shift is 1. You could put n equals 1 right here, and just to show that real quick, we're just going to shift the maximum, keep it as 20 for a second. We'll shift this down so that we can test against the cumulative max above it, like that. So at the 16th employee, when it's that person's turn, the current max will be 87.5, and then its salary is 107, which is greater than 87. So what we'll do here is, we don't need the dot head, is we need to test that the current salary is greater than this maximum that's shifted down 1. And we do have to be careful here of this missing value, or else the first one won't. It's only the first entry that will be missing, but we need to do fill NA of 0 over here, just so that we can have something to compare it to. So sal is unshifted. It's the normal salary of each employee, and it will get tested against the current maximum. So we'll say we'll call this filter, and then we can return df of just these columns that match this filter, where the current salary is greater than the current maximum up to the one above it. Let's go ahead and look at this solution right here, and it appears that it has given us the exact same result, and then we can test it with the assert statement. So everything looks good. All right, so that's a fairly complex challenge. Hope you enjoyed it, and that is it for Dunder Data Pandas challenge number 10. If you enjoyed this challenge and would like to learn more, then come check out my books and courses at dunderdata.com. I provide a comprehensive path for mastering both Python and Pandas to produce trusted results. Below I have a few of my courses. Exercise Python will teach you the fundamentals of Python. Master Data Analysis with Python is an extremely comprehensive course that will teach you everything there is to know about using the Pandas library to do data analysis. And then my newest course is Build an Interactive Data Analytics Dashboard with Python, which is a really fun and exciting course and teaches you all the steps for launching your very own dashboard with Python.